You type one line of text, a snowy forest at dawn, and instead of a picture or a clip, a doorway opens. You step through, walk down the path, turn a corner you have never seen, and the world keeps painting itself ahead of your feet in real time. Turn back and the tree you passed is still there. Nobody built this place. No 3D models, no game engine, no programmer who wrote the rules. A neural network is imagining the whole thing, frame by frame as you move. This is Google DeepMind's Genie 3, and the idea behind it may be the next big leap in how machines learn. Let us see how it works. DeepMind calls Genie 3 a general-purpose world model, one that generates interactive environments from a prompt. From a sentence, you get a world you can move around inside in real time. And the phrase that carries the whole story is this: a world model is not a video model. A video model learns what a scene looks like. A world model learns how a scene behaves. Google's own definition puts it cleanly. A world model simulates the dynamics of an environment, predicting how they evolve and how your actions affect them. Not what does this look like, but what happens next if I do this. And it is the first one you can interact with in real time. Press the left arrow, and the very next frame turns left. The corridor ahead is generated live, one frame before your feet reach it. That is the line between a world you steer and a video that plays at you. It took 3 steps. Genie 1 in early 2024 learned flat 2D worlds at about 1 frame a second, too slow to play. Genie 2, late that year, reached 3D but held together for only 10 to 20 seconds. Then Genie 3 in August 2025 brought sharper worlds, around 24 frames a second, staying consistent for a few minutes. Now, you may have read that Genie 3 has 11 billion parameters. That is wrong in an interesting way. That 11 billion belongs to Genie 1. DeepMind has never disclosed Genie 3's size, so anyone quoting it is carrying an old number forward. Genie 3 is the model. Project Genie is the app built around it, through Google Labs, and it is really 3 Google systems working together. Gemini reads your words and understands what you want. A system called Nano Banana Pro paints the very first frame, the starting image from your text or a photo. Then Genie 3 takes over and generates every frame after that live as you explore. Gemini understands. Nano Banana Pro paints frame 1, Genie 3 dreams the rest. So why is a world you walk through a leap beyond a video you watch? A video generator like Sora or Veo gives you a fixed clip. It is decided up front, plays start to finish, and you cannot change it halfway. A world model gives you an open environment generated as you act. Every move shapes the next frame, and you can step back into a state you already visited. The test flips. For a video, does it look real? For a world model, can I act in it, and does it stay consistent? And the real prize is not pretty footage. It is a learned, interactive simulator, a place to practice. Train a robot, rehearse a rare emergency, explore a what-if, with no artist building assets and no programmer coding physics. That collapses building an interactive world from the job of a whole studio down to a sentence. There is a bigger claim around this, which you should hear as a viewpoint, not a settled fact. Many researchers argue that world models are the next frontier, beyond today's language models. A language model predicts the next word. A world model predicts the next state of the world, which many argue is what you need for real physical reasoning, for robots, for an AI that grasps cause and effect. The bets are enormous. Yann LeCun left Meta to start a lab on exactly this argument. Fei-Fei Li's company, World Labs, ships world models it calls spatial intelligence. Meta has its own, used for robot planning. So take this seriously, but as a thesis smart people are betting on, not a proven destination. Now the part almost every article skips. How does Genie 3 build a world frame by frame? It is autoregressive, a fancy word for a simple idea. It makes one frame at a time in order, and each new frame is built from everything before it. To draw the next frame, it looks at 2 things: the world description you gave and the entire trajectory it has generated so far. DeepMind says it plainly. During generation of each frame, the model takes into account the previously generated trajectory, which grows with time. And here is the single thing that turns this from a video model into a world model: action conditioning. A video model takes one input, your prompt, and produces a clip. A world model takes your prompt and at every step also takes your action, the button you press, the direction you move. Researchers write it as a contract. State plus action gives the next state. That second arrow, your live action every frame, is the whole reason one is a video and the other a world. Now the deepest, most misunderstood part. How does the world stay consistent? You turn away from a wall, turn back, and it is still there, same color, same cracks. So Genie must be storing a 3D map somewhere, right? No, and this is the misread to unlearn. There is no explicit 3D model inside it. Compare it to NeRF and Gaussian splatting. Those reconstruct a scene into a stored 3D shape you can orbit. Genie does nothing of the kind. Its worlds are created frame by frame with no saved mesh. So where does consistency come from? It is emergent. It lives in the network's internal state, and in that growing trajectory, a visual memory reaching back about a minute. The wall persists not because it was filed away, but because the network remembers it and repaints it fresh every frame. The NeRF world is stored. The Genie world is remembered. There is no map, only memory. But where do the dynamics come from, and how does it learn your controls just from watching video? DeepMind has not published Genie 3's exact recipe, so let me show you the approach from the original Genie paper. Genie 1 was trained on unlabeled internet video, tens of thousands of hours of gameplay, with no action labels at all. Nobody told it which button did what. It had to discover the actions hidden inside ordinary video by itself, using 3 learned pieces. 1. A video tokenizer compresses each frame into a few discrete tokens. 2. And this is the magic. A latent action model looks at 2 frames in a row and infers the hidden action that took you from one to the next, squeezing all of motion into a tiny vocabulary of just 8 invented buttons. 3. A dynamics model takes the past frames plus one of those actions and predicts the next. Compress the frame, guess the hidden action, predict the next one. The middle box is where the controls are born. And now the most elegant idea in the whole system. That latent action model, the part that taught itself 8 hidden buttons from passive video, gets thrown away. At runtime, when you actually play, the entire action model is discarded and replaced with actions from you. During training, the arrows point inward. The model watches video and infers what action must have caused this change. It builds a meaningful action space on its own. Then at runtime, your keyboard plugs into the exact same slot. The buttons you press map onto the action vocabulary the model taught itself. From video, it was never given the controls for. It learned what a button is, then handed the controls to you. And the same recipe works beyond games. Feed it robot footage and it learns actions there too, which is why the paper calls Genie a foundation world model, the bridge from a 2D toy to a robotic simulator. So what can you do with all this? You navigate a generated world in real time. You can ground it in a real place. Drop a pin on Google Maps and Genie anchors the world in Street View, though that grounding rolled out in May 2026 and at launch covers United States locations only. You can change the world with words, what DeepMind calls promptable world events. Mid-walk, type make it rain. But that was shown in the August 2025 research preview, not yet in the Project Genie app. And the use that best shows why a world model is special is training an agent inside it. DeepMind ran a learning agent called SIMA inside Genie worlds. Genie is the teacher building the world. SIMA is the student given a goal, pursuing it by sending actions to Genie, which answers with the next frame. And the beautiful detail: Genie is not aware of the goal. It just simulates the future from the agent's actions. The world is neutral. The student supplies the intent. And this ships for real. In February 2026, Waymo unveiled a driving world model built on Genie 3. It generates camera and LiDAR, so it produces real depth, not just pixels, and engineers turn 3 dials. Driving actions, what if the car swerved? Scene layout, the road and traffic. And language, the weather and time of day. The point is rehearsing the long tail you can almost never film. Tornadoes, floods, wrong-way drivers, even a stray elephant in the road. Waymo has driven nearly 200 million autonomous miles for real, and billions more in worlds like these. Let us place it next to the things it is confused with. Against a video generator like Sora, the generator outputs a fixed clip you watch. Genie outputs an open environment you steer and can re-enter. Against NeRF and Gaussian splatting, both make 3D, but those capture and store one real scene as fixed geometry. Genie generates new, changeable worlds with no stored geometry. Capture versus simulate. And to be fair, Genie 3 is one of several world models, a leader on the real-time interactive axis, not the only player. DeepMind is also careful to say it is not a game engine. No authored rules, no guaranteed physics, just a learned approximation that can drift. As for using it, Project Genie runs through Google Labs as an experimental prototype on Google's AI Ultra plan. It launched in the United States in January 2026 and went global to all eligible Ultra subscribers worldwide in May. Treat the price as a moving target. It was reported around $250 a month early on, then Google restructured to a $200 a month tier that includes Project Genie by mid-year. And one session gives you up to 60 seconds of generation. Now hear its limits as the current edge of a young technology, not things machines can never do. Consistency lasts minutes, not hours, so wander too far and the parts behind you can drift. Resolution is around 720p, not 4K modeling a busy crowd, each character doing its own thing, is still an open problem. One actor exploring works beautifully. It approximates the world rather than computing it, so geography can be warped and physics a little off, and it will not always follow your prompt exactly. And text inside the world comes out garbled unless you put the exact words in your description. So step back and look at the shape of this. For years, the big leaps in AI came from predicting the next word, until out fell something that could write and reason. A world model takes that same principle, prediction, and points it at something bigger. Not the next word, but the next state of the world, given an action. A learned, runnable simulator of reality. If that direction holds, it could underwrite robots that practice in imagined worlds before they touch the real one. Agents that plan by simulating a move before they make it. Self-driving cars that rehearse the lethal moments they could never safely film. And classrooms with explorable simulations of anything you can describe. DeepMind itself frames Genie 3 as a stepping stone toward artificial general intelligence, through that same teacher and student loop. But hold that as DeepMind's framing, a bet, not a proven fact. Honest people disagree about whether this is the road. So here is the question to leave you with. For a long time the test of an AI was, does it look real? World models change it to something deeper. Can machines learn to act inside worlds they imagine for themselves? Watching Genie paint a forest you can walk into, with no map and no engine, just memory and prediction, you feel how close that has become.